Hello. Hello, everybody. Welcome to my talk on defragmentation of the mobile web. Glad everybody can make it out. Super excited to be here. So again, thank you for coming. So this talk is going to cover a few HTML5 APIs and how those are used on mobile devices. And this presentation, this framework is actually based on WebSockets, and that's going to be, we'll go into the demo in a little later, but so this slide deck is kind of like an experiment a little bit for WebSockets and the mobile web and the use cases that are involved with the mobile web. So if you want to participate, you can go to that address at the onslide.com/devox12. And what you'll have is that will bring up a remote control, and you'll be able to choose which direction I go. So what this does, it establishes a WebSocket connection to the phone, and I have my little EC2 T1 instance running on the cloud. It's a little free instance, and it may crash. This whole thing may crash, so if it does, again, this is just an experiment, but it will allow you to vote and choose the direction I go. So it allows me as a presenter to survey the audience. So that's kind of the rundown of what this tool is. So let me go to the first slide. So here is the first slide, and basically it asks, so I can get a feel for the audience and so I can understand what your skill level is. It asks you, have you created a mobile web app? And as you can see, the results start pulling in from all the people who are voting. And this is the use case for the real-time web. The web is moving forward in many different ways, but the real-time web, WebSockets, Speedy, server-sent events, all these different new protocols that allow connections in real time are going to influence the way we write applications. So when someone says, why should I write a native app over a mobile web app, this is the case right here, because everyone in the audience who is participating, we're up to what looks like 52 votes. It's hard to tell. Prototype needs work. But anyway, this is the case, right? You instantly can pull up this remote control. You can interact, and you are now part of the conversation, so to speak. With a native app, I would have to deploy this to the App Store. They would take 30% off the top of my profits, and even if it was free, it wouldn't matter, because you're not going to sit there and install an app and wait, and we're not going to wait for this presentation to continue. So this is it. So this is the WebSocket use case, and we'll talk in detail about WebSockets in a minute. So obviously, the majority of folks in here have created a mobile app. I wonder how many votes that is. That's a few. Okay, so good. So the majority of you have created a mobile app. See, if everyone would have said no, it would have went to a different slide. So, all right, so enough about that. So let's talk about fragmentation. So there are a lot of platforms and a lot of browsers out there on the web today, and you want to write your application to span as many of those as possible, right? So one of the ways that, like I was saying earlier, the current argument is native versus HTML5. It's an old argument. People are tired of it, and everybody knows now that HTML5 mobile web apps are desktop. It doesn't matter if it's mobile or desktop. They have their use case, and native has its use case as well. So just to give you an example, so Facebook, they were at QCon last week, and they were talking about how 7,000 types of mobile devices use their mobile website every day, and a third of that number of their actual traffic comes from their native devices, or native applications. So it doesn't matter, even if you want to write a native app. In a case like Facebook, you have to write a mobile web app regardless, and you have to support it. And also the Financial Times, another use case in the US, 30% of their page views and 50% of new subscriptions came from mobile after they rewrote their native iOS app. So they talk in this article about how much more money they made and all this stuff. And so news sites, obviously, I came from CNN, that it makes sense to have a mobile web app for those types of use cases. So I see some WTFs. By the way, WTF, if you weren't in my talk on Monday, WTF stands for why the face. So just to let you know. Okay, so what are some of the problems? So, everyone was saying mobile first, content first, API first, user first, and me first. Yeah, so you can sit here, and I was saying offline first on Monday. I mean, it's all these different methodologies and ways of approaching development. But I thought it was funny. I saw this tweet from Luke Rabolski yesterday, and it reminded me of this picture. When you have me first, sometimes when you go first, you don't get what you expect in the end. Kind of like this deer here. So so sometimes being first and thinking first about all these things, you end up getting screwed because you're overthinking the situation. You just need to take a step back and understand the problems and come up with a decent approach. So what are some of the problems? Yep. So let's start with JavaScript applications are not SEO friendly, right? Bots and crawlers cannot parse JavaScript at the moment. I hear Google's working on something. But, they can't parse the JavaScript and interpret the page for you. So, yeah. So, some of the options are server-side pre-rendering. People are trying to come up with different strategies today, but the overall message is that JavaScript-heavy client-side applications, like what we talked about, offline first, mobile first, they're for a specific use, and usually that's for maybe an internal app or a CRUD app, create, read, update, delete. But, it's just, it really depends on what this app's going to be used for. And then if you do want it SEO capable, you have to think about how you want to handle the content. So most companies only focus on iOS or Android. When I was at CNN, and other companies for that, and other companies for that, and all they really cared about was iOS and Android for their mobile web initiatives. And that's easy to say from a developer standpoint. It's easy to do because the development flow for writing mobile web applications is, you pull up Chrome or Safari and you kind of write it there in the browser on your desktop, test it there, and then push it out to the iOS simulator or to the actual device, and then you test it there. So that's kind of the flow that happens. And it's easy to support. But the thing is that it's not as easy as some people think because of fragmentation. Even with iOS, there's fragmentation. With Android, we all have probably heard about the fragmentation. And that's the inability to write code and run it anywhere. Write it once and run that code anywhere. So HTML fragmentation deals strictly with how the browser APIs access hardware and other device failures. So basically, when you go to access the geolocation device or the accelerometer or the camera or whatever on this device, some platforms are going to allow that, some devices are going to allow that, some browsers may or may not allow that. So it really depends on the APIs available through the device and then through the browser as well. And so it can get kind of tricky, and it's a really messy matrix of support and trying to figure out who supports what. So today we're going to focus on 5 APIs, and we'll go over those in just a minute. But the reason for that is, of course, there's a ton of other HTML5 APIs out there. But what I want to, I guess, enterprise developers more than anybody really, as I've gone from development shop to dev shop over the last year, I've seen that nobody's really using HTML5. Yeah, it's there, and we know we kind of can support some browsers now for it, but a lot of people aren't taking advantage and having kind of a building block foundation of HTML5 APIs, and so that's what we're going to talk about. So they're going to, developers need a starting point as well. So it's easier to grok. Let's just start with 5 and then we'll build out from there. But looking at the 5, we want the ones that are most widely supported across all browsers. So how do we define the starting point? So let's take a look at our target browsers first. What kind of browser are you using right now? So let's see what the majority of the audience is using. All right, so Android's winning, or other, but probably Android. So yeah, it's awesome. Cool. So that gives us an idea of the next section, because we're going to go over some numbers here. Interesting. All right. So mobile Safari. Apple sold 5 million iPhone 5s in 3 days, and that's pretty impressive. I mean, we all hear these numbers every time a new iPhone comes up. They're like, Apple sold 1 billion phones in 1 hour. And so, getting kind of used to hearing these numbers, but still, it's very impressive for our job. It's very, we have to think about these things for our future and our job, for our developers' jobs, because mobile is coming rapidly. So they have, right now, iOS has 61% market share. That's iOS 4 through 6. It's a large, and that's why I was saying earlier, most companies only target Android and iOS for development. And it makes sense, right? You're kind of killing a really big bird with one stone there. So the upgrade delay for iPhones is very slim. Typically Apple users upgrade immediately when the operating system comes out or shortly after. Couple reasons for that. App Store developers usually only develop for the latest version -1. Most developers I've talked to, that's they're not going to support the older operating systems and older phones for iOS. But the problem with that is iPad users are a little slower to upgrade because I gave my wife my wife took over my iPad. I bought it for me, but she took it. So anyway, they don't typically. I don't monitor that device, so I'm not going to stay on top of it. And then the iPod Touches as well. So those devices, along with not being able to upgrade past version 4. So some of the legacy Apple devices cannot go past iOS 4. So the fragmentation is still there. Apple can lead the market, and they can have really good adoption of upgrades, but it's still going to be there for us developers. So Android has 23 manufacturers and 272 device types. That's a lot of devices to support, and a lot of different operating systems spread over. So if you go out to Android.com, you can see they just have one huge page of all the devices that support Android and the build for Android. That's a hell of a lot of devices. So in 2011, Android had 190 million activations. In 2012, they had 500 million. That's 2.6x increase in 1 year. So with Android comes the fragmentation, and the iOS fragmentation is not as bad because even the older mobile Safari versions are easy to develop for. They support GPU access through CSS3. They give you different APIs to work with, and it's remained pretty steady because they were very early HTML5 adopters. But the Android default browser is really a thorn in the side for a lot of developers, especially with Gingerbread still maintaining a large percentage of Android's market share. So Gingerbread is version 2.3, and it came out on like the Evo 4G and some of the I think the Galaxy 2S as well. So a lot of very popular devices support this operating system. And then Ice Cream Sandwich, which some manufacturers won't provide upgrades. So even though they have Gingerbread and they have this great phone, you can't get an upgrade to version 4 because the manufacturer will not provide that. So kind of locks you in. So Android has 21% of the market. And this gives WebKit a really big hold, as we'll see in just a second. But they have version 2.3, which is Gingerbread, has a 35% share, and 4.0 has 45%. The others, the long tail of the Android operating systems, have 20%. So the differences between 4.0 and 2.3 are pretty significant. 4.0 is a little better, but there are some, you still have some of the crazy differences to deal with. So WebKit. So with Android and iOS having this huge percentage, 80% market share right now today, which will change eventually, WebKit has also seen a great deal of commits and revisions over the past year or two. And this chart kind of shows as iPhone was released, and you've got Chrome getting in the picture, and then Android browser as well. So it's literally shot through the roof as far as WebKit's community activity. So let's look at Internet Explorer. So those were the two big players, 80% of the market. That's why it's so easy to say, hey, we'll just cover Android and iOS, and we'll be done. That's our mobile web application. But there's still more players coming, and we're just in the infancy of this. If you look at Internet Explorer's and BlackBerry's strategy, they're both pushing hybrid apps. They want you to use HTML5 and CSS to write a hybrid application which can go into their app store, which is appropriate because it's an easy barrier for entry for developers, and it allows them to gain some traction in the market. But Internet Explorer sold 4 million Windows 8 upgrades in 3 days. So that's pretty impressive. Even though those are mostly desktop computers, people are still using Windows. They're still huge Microsoft fans, and that is what they're going to continue to use, and they're going to buy tablets when Microsoft brings them out. So they do have somewhat of a loyal following. Even Arnie Schwarzenegger said they asked me to upgrade to Windows 8, but I said I still love Vista, baby. I still love Vista. That's good. Yeah, that's great. And they also have Minesweeper, too, as well. So for those, I don't really know. That would be great if they put it on their new Windows 8 tablets, but I don't think they did. So Windows Phone IE10, Windows Phone 8, IE10, really good browser. It supports a lot of things that we're about to go over. And it currently has about 1% of the market. So it's going to continue to grow. I mean, Microsoft just recently released and did this huge marketing push. So we're going to see those numbers go up. And then one thing I'm really excited about is Firefox's mobile browser, mobile OS. So they have a mobile browser which is available on Android, and it's really good. It trumps iOS 6 or iOS 5's mobile Safari browser. But Firefox also has this project called the WebAPI project. And it basically is an HTML5 based operating system which will give you, and the WebAPI project driving this makes available all the device APIs like the address book, the instant messaging, the camera, all the obvious things, along with all the things that only native app developers currently get with platforms like iOS. So this is huge. I know they've released some phones already, and I know I bought a Galaxy S2 off eBay just so I could flash it with this operating system. So if you go out to Mozilla's website, they make it really easy. You can just flash your Android device with the Firefox OS, and it's all HTML5 driven. Opera Mobile, right now Opera Mini has a really big market share, around 8%, but it's shrinking very quickly. Over the past year, it shrank from 18%, and now it's 8%. So the Opera Mini browser is not really a HTML5 capable browser. It's more of a rendering engine, and it comes back from the server with the content you need. So you don't have anything like local storage or the geolocation API or any of those things. But Opera Mobile, the browser that's available on Android devices, is really good. It's really solid, and it has great support for HTML5. So that's our happy family. As a developer, like I said, you can choose to only support WebKit, or you can choose to support the others just as easy, because sometimes those browsers are better than the actual WebKit browsers. So you're sitting there, you have your extra monitor on your desktop, and you have about 3 or 4 different emulators open, and you're just going through and hitting refresh on those emulators. So there's a lot to do as far as testing goes, but the browser rendering engines are really, really good, so that's what we're going to talk about. So next, the APIs that we can use with all these cool browsers. So there's this website called HTML5e.org, and it's where I created this site, I just defined, I said, here are the 5 most widely supported APIs. Here are the 5 most supported browsers. And you can use those APIs across the browsers. Now, the support is not 100%, but it's, I wanted something that was easy for developers to grok, to understand, and to start with. Building, instead of looking at the HTML5 spec and going, I'll pick this one, this one, this one, and it may or may not work on whatever device you're targeting, whatever browser you're targeting. This is like a solid, I spent a lot of time just trying to figure out, what could work most across all these devices. So let's start with WebSockets. This presentation is based off WebSockets. The slide deck is heavy client side, it's all JavaScript, and it makes a very light connection to a WebSocket server I have running on the cloud. And if you look at the bottom green numbers going across the bottom, well, actually, if you look at the top first, for each one of these 5 specs, we're going to go over all of the coverage. So WebSockets, green, IE10, iOS 6, and back. Android still does not support WebSockets. Opera Mobile, BlackBerry, Chrome, FireFox. So you're good for the most part. You can, with WebSockets, you can provide a graceful fallback to polling, long polling. Frameworks like Socket.io, which we'll go over in a minute, give you those things. So, and Vertex, yeah. Every HTTP request sent from the browser includes headers. So the reason we need WebSockets is because HTTP is very inefficient in maintaining a connection. Like if we maintain, I don't know how many devices are still online with my server, but being able to maintain a connection, there's one, allows you to do things like this and to really write really cool applications. So WebSockets gives you minimal overhead with full duplex communication through a single socket, like I just said. And this is the demo for it. So we don't have to go too much into the code, but this is basically it. Let's see. So what are some of the libraries? Vertex, which is a really cool up-and-coming WebSocket, which is actually, I want to convert this prototype I've written to Vertex. And then there's Socket.io for the Node.js fans, and also Atmosphere, which I've used in the past as well. When I was on the Rich Faces project for JBoss, we used Atmosphere in our Rich Faces push component. So that was a really good project. They cover, if you go out to Atmosphere's GitHub repository, they have a ton of example projects for every framework out there. So they've done a good job with that. So next is web storage. And web storage is a fairly simple API. It allows us to store on mobile clients up to 5 megabytes of data. That's kind of elusive because it's really UTF-16 encoded, so you only get about 2.6 megabytes. But the coverage is really nice. The only drawback to web storage is security. So web storage is not really the evolution of cookies. It's more of a complement to cookies. Cookies have their own purpose, and that's to send data, implicitly send data to the server upon each request. And web storage is more of a offline first kind of tool to where you can build an offline capable web app and use that data to efficiently load resources later for the user. So obviously cookies, you don't get very much. So with web storage, like I was saying, you get 5 megabytes on the device and really 2.6 megabytes if you're going to store something like HTML. So there's 3 ways of accessing or storing data in web storage. And one of those, the first one, you just call the variable name and you store it. The next one, you use brackets, store it like that, and then set item and the name of the key that you want to store data on. So that's pretty simple, right? So why do we need 3 ways? I mean, that's JavaScript. That comes naturally with the language. But what you don't know is that web storage performs differently on different browsers. So this perf test was done with Chrome. And as you can see, we're setting the first two rows at the top set a small and large value. Then the other ones set it the same values using the different accessors and the ones I just showed you. So if you use the brackets down at the bottom where the green square is, that's going to be the fastest way to store data in Chrome. And so it's really crazy how you can optimize the performance of storing the data. You would think they all perform the same way, but they do not. So in Firefox, it's different. This way that's fastest in Chrome is not the fastest in Firefox. So once you have a really optimized site and you're really looking to tweak things out a lot more, this is where you want to look, is how are these APIs, how are these browsers storing data, and how can I improve them? So one of the frameworks so web storage, to get the biggest bang for your buck is to really, first understand the API and then bring in a framework. And there's a really well-supported framework from the community, from Brian LaRoe, which is called Lawnchair. And basically, when you want to save data, you just do this function here, and that's basically it. It covers all the browsers. So from BlackBerry to Microsoft to WebKit, it has a lot of different plugins as well. So Lawnchair for just to make life easy when you want to use web storage. All right, so next, let's look at the orientation API. So again, this is another API that has solid coverage on the latest browsers and some of the older browsers as well that hold 80% of the market. So again, this is the reason we're going over these 5 APIs. So let's look at a demo. That's not the demo. Oh, we're not ready for the demo. Okay. Standard user interfaces are an illusion. So basically, what I'm saying is, the interfaces we have today are built for the desktop. UI developers are just coming around to building user interfaces for mobile devices and using touch interfaces. And those touch interfaces, with those you can cut through that particular illusion and let people interact directly with the content. And the same goes for the orientation API or the accelerometer and whatever future APIs will come, whatever future hardware devices will come. We have new ways of interacting with content. Today it's touch, tomorrow it'll be something else. But for that, we have a demo. So what this is a demo application I wrote that uses, it was actually built to just say, okay, if you were in my talk on Monday, it was what is required to build a mobile web app. I just want the minimum. I don't want any frameworks. I don't want anything else. I just want CSS, JavaScript, and HTML. What is needed to make a native-looking mobile web app? And that's what this is. So it's very minimal. There's no frameworks involved. This uses the core accelerometer API. But in the normal app, actually, let me pull up the normal app. So the normal application, it uses prefetching and nice slide transition and flip, and it's for mobile devices. It's running right now on a desktop, but it was built for mobile devices. So this is the exact same application, but using the accelerometer API, I can tilt and navigate to the other pages. So I'm going to drop my hard drive here in a minute. So anyway, I don't want to unplug my SSD here because that would be a disaster. So anyway, the orientation API is allowing me, and if you pull it up on your phone, it's a lot easier, and it makes a lot more sense. So actually, let me do that. Yeah, so here, we just kind of go through the pages. And this would be good for like an image slideshow. There you go. Can you see it now? Yeah. So you can go to pages, you can navigate, all those cool things, right? All I thought orientation for was to get my north heading for maps, but boy, was I wrong. So you can use it for scrolling long pages, extremely long, responsively designed pages. So a lot of uses there. So Next is geolocation. Again, very widely supported across all the different devices and browsers, and we can use geolocation for a lot of cool things. Gives us scripted access to geographical location associated with the hosting service. So it really depends on the carrier and the device on how this data is acquired. But a few of the uses are geofencing, which is mostly used with native applications. So draw a radius around where the user is and only show them certain ads for that particular location. That's what we can do, right? And then there's geocoding, which we can also look up the address based on the location, the latitude and longitude of the user, and just general tracking. The API itself is device agnostic, so it doesn't care how the location is determined. It could just ask the user for a zip code. It could use Wi-Fi. It can use GPS. Again, it's dependent upon the device and the carrier. So there's a bug in iOS, or actually in WebKit, that depends on all of these APIs use a simple detection method, and this is it right here. So you check for that object, whether it be local storage or orientation or geolocation, you check for that in the window object, or in this case in the navigator object, because if you use it using a dot notation, so if I said navigator.geolocation to see, hey, is this device supporting geolocation, it will prevent the page from actually caching in the browser. So there's a lot of these little nuances when developing for mobile apps, a lot of little bugs that you'll have to account for, like this. So demo's simple. Just get the latitude and longitude. Another important note with geolocation is that in iOS devices on mobile Safari, it's broken. The watch position, I think, let's see. Yeah, so watch position has a bug as well, and basically what will happen is here I'm just setting an interval to get the current position, but the API itself has, you could call navigator.geolocation.watch position, and it will track the user as they carry their phone around. It's built into the API, right? But if you use that on iOS devices, then it'll crash the browser after 4 minutes. So that's, again, another issue with an HTML5 API that you have to be aware of as a mobile developer. So to get around that, we'll just set an interval and pull the actual method that does work. Web Workers, the fun one. So again, Android is letting us down. The default Android browser is letting us down here, but that's okay. We can still use this API and use it effectively. Web Workers spawns real OS level threads, allowing for data to be passed back and forth between any given thread or worker. It's a multi-threaded approach. You don't have access to the DOM, which the DOM is not thread safe, the window, document, or parent objects. You can, however, access the location object, and that'll give you some different information. But really, it's for processing data, and for right now at this point. There's newer specs or newer things to complement the spec, like shared workers and a few other different variations. But for the core web workers that we're talking about today, that's widely supported, we're going to just go over some simple demos for this. So the first one, this is my beautiful daughter, who I miss very much this week. So what it's doing is, let me do that again, taking an image and processing the image data as the browser, oh snap, browser blew up on me on that one. So it's still pretty experimental. But each row is being passed to a different thread, and that thread is processing the data and then handing it back to the browser to the main thread. So let's look at that and see how it works a little better. So here is, let's see if it processes it. There we go. So it's all dependent upon the browser, but this little table here is very simple. On the right side is the thread ID, so I have 8 threads available, and on your left side is the data, and all we're doing is coming up with prime numbers. We're going from 200 down to come up with some prime numbers, and each thread is processing those worker chunks, and I'll show you that. So right here, we're adding a worker task, and we're setting 10, 20, 30, and we're adding 4 quick tasks to this thread pool, and it's going out and processing the prime numbers and bringing them back to the browser. The actual thread pool is pretty simple. Here you give your pool a size, and it's maybe 100 lines of JavaScript, but I can show you guys afterwards if you want to see it. I cannot take credit for it, but I did hack it a little bit. So yeah, that's it. That's a thread pool with web workers. So now we can process that data more efficiently. And in Chrome, where you actually get threads from the CPU, your browser becomes really powerful. So each browser handles it differently, how they process web worker threads, but I know Chrome does a really good job of it. And I believe that's it. I ran a little short, but I'll open it up for questions. If anybody wants to see anything, you can hit me up afterwards. Oh, yes.
Are there any frameworks or JavaScript libraries that do or are quite up to date with hiding the differences and the bugs, and which one deals with all the little bugs and changes, and then can, for example, the storage API can optimize for the specific or do the appropriate call for the specific browser it's running in?
Yeah, so he's asking the question of, are there frameworks to where I don't have to worry about all these bugs, and is there a community effort where we can just go and get a framework and everything works and is efficient? No, that from my research, I haven't found that. There are wrapper frameworks, there are fallbacks that support these APIs in older browsers, and I'm sure some of the frameworks use efficient methods, like for the web stores thing, to store the data. But it's really up to the community, us, I guess, to go in and say, okay, here's a contribution to this framework to make it faster. But I have yet to see a framework that covers all of these bugs. So, actually, I kind of wrote the framework with the demo. I'll show you guys the code real quick that is driving this. Yeah, so then the name of the JavaScript framework is called Slidfast, and it's just a learning framework for me personally, and to show the readers of the book I wrote how to do these things, and it handles all the bugs that I've found over the past year, and so any contributions to that are, if anybody wants to help turn this into a project, then I'll be more than happy to do it. So it goes over, I'll be more than happy to do it. So it goes over everything we talked about today. Anything else? Yes?
I'm not sure, maybe I missed that, but what about Canvas?
Canvas, yeah, like I said, I'm trying to stick to the enterprise developer and the data needs and what is widely supported across. Yes, Canvas is widely supported as well, but I'm not worried about drawing graphics per se. I mean, in this framework I wrote, Slidfast, you can base 64 images and convert those to a string. That is a very useful feature of Canvas. And so Canvas has its uses. I just did not have the bandwidth to go any further than those 5 APIs. Yes, there you go.
How quickly are the performance statistics for the different browsers changing? You showed some statistics for WebSockets,
Yes.
but there's still lots of development. In your experience, how quickly is that changing for browsers?
It's changing very fast. The performance across all the different browsers is changing. Obviously, what we're looking at today could be a bug that could be fixed in a future revision, or it could just stay that way. We don't really know until we report it and get involved with the project. But the basic thing is, not only do we have fragmentation to deal with, there's a lot more under the covers of browsers themselves to deal with. All right. Well, thank you guys so much for coming. I appreciate it.